Welcome everybody. This is the 7th COVID-19 Robots and Us discussion. I can't believe that that it's already May. People are starting to call this the new normal, but I don't think I feel like things are normal yet. Today, I've invited a lot of robotics startups, roboticists who are very experienced in a wide range of robot startups to talk about their experiences. And hopefully we're going to dive into the new normal, the good, the bad, and potentially the ugly. So as I speak, I've just been reading an article that said that in 1980, the volume of medical knowledge was doubling every 7 years, and now it's doubling every 73 days. But it really feels like it's more like every 73 hours right now. Things are changing that rapidly. And we think that things are changing rapidly in robotics, but is that really true? Well, before we kick off with the discussion and our fabulous speakers, I just want to give a shout out to the crew, Bo Amber from Kickstarter, who's manning the Zoom, and Erin Pan, our Stanford MBA, who is looking for autonomous vehicle opportunities, who's been helping me collect the questions and organize the chat and share links. Final housekeeping, if you're not a speaker, please keep your video off and your mic on mute. If you have a question, please put it into the chat. We're looking for a really active discussion here today. And we have great guest speakers today. We, touch wood, have David Crawley from Ubiquity Robotics, but he's calling in from Europe. So I'm not totally sure about that. We also have Ian Bernstein from Misty Robotics, Katherine Scott from Open Robotics, Nikolaus Correll from Robotics Material Handling, and Rikke Rasmussen talking about liquid handling robotics, alongside Ken Goldberg, the director of CITRIS People and Robots Initiative at UC Berkeley, and Jessica Armstrong from SuitX, who's an open source COVID-19 medical supplies, who's going to give us a rundown on what's been happening in the world of community COVID response. So now that we've had the overall introduction, what I'd like to do is hand over to Ian Bernstein from Misty Robotics to give us an introduction to Misty and everything that you've been building.
So Misty Robotics has been around for about 2.5 years. Before that, for about 2 years, we were a product team within my last company, Sphero. We made BB-8, Sphero, and lots of other products. So the idea behind Misty is a more advanced robot, a robot that can actually do real stuff for us in our homes and offices, businesses, and it's an open development platform. So Misty, she responds to her name. So voice recognition, we have far field microphones, we have a high-res camera for computer vision, a structure sensor for mapping and navigation. She's mobile, so there's little treads on the bottom. Charges wirelessly or with a DC plug, capacitive touch panels. So you can build in a lot of personality, and most of the applications for Misty sort of play into that personality piece, like different applications where human interaction is important. So we started shipping Misty in September of last year. And our customers are mostly businesses, again, that might have an application for a robot, but they don't have 4 years and $16 million to build their own robot. They just want maybe have a software development team, don't know much about robots, so they can program their skill and hopefully deploy their skill for Misty. So languages, so Misty natively on the robot, you can program a skill in JavaScript or C#. It also has a RESTful API, connects to your Wi-Fi network, so you can also run your skill from your computer. And in that case, using the RESTful API, you can use whatever language you want. Speaker system, there's a backpack on the back. It's magnetic and pops off. We have an Arduino version of this as well, so it's super easy to hook in other sensors or motors, actuators, servos. The whole thing is pretty hardware hackable. So one screw, the arm pops off, and you can 3D print your own arms. There's different panels, like this head piece is also magnetic. So I'll talk about that in a second. There's a trailer hitch, and then lots of time of flight sensors for edge detection, frontward time of flights for obstacle avoidance. So you can check out all the different features and capabilities on our website. But right now, like our customers, we've sort of seen two groups starting in September when we were shipping. Lots of people working on different things, but the main sort of core groups were one in elder care, looking at things like companionship, safety, using the camera for fall detection, the microphones, the far field microphone array for audio localization. So if somebody makes a loud noise or screams, the robot can go check it out and ask if they're okay using voice recognition. And then the other area is sort of in therapy, mostly for children's therapy, working with kids with special needs, working with social interaction. And I'm sure a lot of us are familiar with all the different reasons why robots work well in that space. We were going into a couple pilots right when COVID became a thing. We had one partner we were working with in the elder care space that was just starting a pilot in Europe. We had a couple of our engineers over there that the same week that they sort of closed down Spain. We had to get our engineers out before all the airports closed. We had another one already a couple weeks into a pilot in the children's therapy space. Of course, they went on lockdown and couldn't work with any of their clients, so that stopped. So unfortunately, a lot of the projects that were just getting rolling kind of stalled out, at least for the time being. So right now, we're investing a lot of our time internally. Now that some of our customers are sort of in a pause mode, exploring some of our own applications for Misty and trying to find partners that have expertise in different areas related to COVID. So I'll post our links in the chat. But if you look at our YouTube channel for Misty Robotics, we have a couple videos of prototypes that we put together where Misty can do temperature checking. So we use this panel on the top, and we 3D printed a little bracket for a temperature sensor. So sort of a greeter / screener. So like Misty is sitting at the reception of a business, and someone can walk up. Misty will take their temperature. She can ask a couple questions, and it'll log the data into a database along with a photo if somebody is over temperature. So exploring applications like that. Also a video of sort of disinfecting. And it's a prototype, right? We're just sort of using these videos to test and reach out to new potential customers.
Well, that's fascinating. I've asked in the chat, do people have ideas for how they would use Misty? It could be a good opportunity to get feedback, but you really, I didn't realize just such a short time it's been since Misty was released, and it's really dreadful timing that, I know there's a lot of worse things that have happened with the pandemic, but you're a robotics company that's really had, this hasn't helped, just to put it mildly. And you're being quite creative now in how you go about deploying or just dealing with the situation. And, what occurred to me is that you're really probably one of the world's leading roboticists when it comes to building consumer grade robots, because there are very, very few companies. We can look at iRobot and that's really about it. And yet you've successfully deployed multiple robots to a consumer market.
Yeah, we definitely shipped millions of robots at Sphero. I think it was, when I was there, it was over 4 million.
Yes, so I think, iRobot, DJI, and you probably, you're really understand a lot about putting bang for box, as it were, condensing components into a small footprint and making something very reliable and robust. Now, just out of curiosity, how do you manage to do a lot of that reliability testing for a product that's really so new? You're using the latest components.
Yeah, I mean, it's definitely tricky. I mean, a lot of it's just thinking of all the edge cases that somebody might do a lot of life testing. So, you know, like at Sphero with BB-8, I mean, we literally had tens of hundreds of BB-8s driving around 24 hours a day. As soon as the battery dies, somebody picks it up, puts it on the charger, waits till it charges, and puts it back down. So we did similar things with Misty, just trying to think of different materials, like, you know, dirt and hair on the floor and carpet and hardwood and concrete and different surfaces, and Misty's just driving around literally 24 hours a day, trying to make them as robust as possible. Our manufacturers also, they're experts mostly in the toy space, but that can help a lot with cost reduction and sort of creative ways of designing things, whereas, you know, from an engineering perspective, we might, you know, think of sort of the elegant, more robust engineering method, but it's not necessarily cheap. But they have super creative ways of sort of getting around a lot of the, you know, problems that we might have.
We've got a few questions, including from some of the speakers. Ken, would you like to go?
Oh, great. Thank you. Yeah, thank you, Ian. I'm a big fan of Sphero. BB-8 was a fantastic product, and I mean, had so many interesting features. I remember being blown away the first time I started playing with it. One thing I'm curious about, just watching the interaction with Misty there, Misty has this really, you know, elegant design, and also sort of, because I've seen a lot of robots that have, you know, this uncanny aspect, you know, they're uncomfortable, but it really feels comfortable sitting there, and also the movement of the head and the blinking and all this. And I'm wondering, what are your thoughts on the potential of robot companions? I think there's been a lot, you know, people have talked about this for years. I think it's always been a struggle, but right now we're in a situation unprecedented where people are really alone, and no one can visit them in senior homes and things like that. So I'm just curious, like, I know it's not a substitute for human, right? We know that, but what could it do that? And could it develop a personality that would essentially learn to respond to, let's say, a senior and start to interact with them on a daily basis? Is that one of the use cases you're thinking about?
Yeah, definitely. On the personality side, we've tried to make it easy for developers. So right now, like what she's doing now, blinking and looking around, this is part of the skill that we wrote. We call it the capability skill. So it just shows off a lot of the functionality of Misty. But we have like 70 different eye assets for different emotions. We have sounds, tons and tons of sounds. There's a sound pack that developers can download and use that associate with those same emotions. It's definitely something interesting. The challenge that we've had on sort of that companionship personality piece is, while we know it's important and people engage with Misty. I mean, I've never seen anybody like uncomfortable around Misty. Everybody just wants to run up and engage with Misty. So I think as a companion, it works really well, but people don't associate monetary value with that. So people get it and it's awesome, but they don't want to pay for it. So
okay, I just would say, Ian, the one thing I hear you, but the one thing I would say is that it may change. I mean, I think that we're in a slightly different world right now, and maybe it's only 2 months in, right? But I tell you, I think people are starting to get stir crazy. They're getting by another month or so, people are going to be desperate for interaction. And if you're sitting at home, especially in a retirement center where you can't even interact with the other people in the home because everybody's so afraid of catching it, you're stuck in your room. It's like you're in solitary. So I just would think it might be possible. I mean, this might be the time to open that door, and maybe there is a market. Because if I had a grandparent in the home, I would pay $5,000 right now if that could give him or her some comfort.
Yeah.
And I realize that there's so many programming nuances that have to go into it. It's an incredibly difficult problem. But you remember that movie, Robot and Frank?
Oh, yeah.
That film really changed my mind because I thought maybe it could work someday. So I just a thought.
That's interesting. Yeah. I mean, it could, like you said, people might put value on it now more than the past, and the perception might be changing.
Yeah, I just think it will in the next few months, unless, you know, this opens up. But anyway.
Absolutely. And there's a few more questions. And I can see the resemblance now to the robot from Robot and Frank, a little bit there. So Harrison's asked, can Misty be used for telepresence?
So yes, so one of our last software updates within the last couple of months, we pushed the ability to do video and audio streaming. So that is possible using our APIs.
Excellent. And are you shipping overseas? There are a couple of Australians dialed in who desperately want Misty.
Yep. Yeah, we're international as well.
Oh, well, fantastic. I see a few more questions there and some suggestions for some use cases there too. But I'll let you follow up with some of those questions in the chat and ask Katherine Scott from Open Robotics if she's able to give us a little bit of an overview now of what's happening with Open Robotics.
Everyone's we're all remote, but we were already half remote to begin with, so it's not really affecting us that much. There is a lot of stuff sort of just bubbling up. I'm gonna drop about 50 links on top of you. I think the most interesting one for us is that basically the second generation TurtleBot, somebody just picked one up and is like, let's drop some UVC LED lights in there and start sanitizing hospital rooms, just as like a rapid prototyping platform. The TurtleBot seemed to work great, and that's been going on. There's a bunch of ROS related companies, or ROS using companies basically right now doing COVID response. They don't always contact us, but we kind of hear about it here and there. So I'm going to drop these recent articles if you haven't seen them.
Oh, that's great. There was the IEEE Spectrum article, wasn't there, about the TurtleBot with the UVC for disinfecting?
Yeah, there's that, but then there's just a whole lot of other stuff. Generally, the Open Robotics has a second office in Singapore, and we work a lot with the Singaporean government long before COVID ever happened. But generally, it's not necessarily a response thing. It's if we look forward, just understanding that we're going to have to support healthcare workers when there's an aging population, and how do we make the sort of dull, dangerous tasks in hospitals a lot easier, right? So a lot of our role in Singapore has been, moving supplies, getting robots to multiple robotic fleets to coordinate inside of hospitals and that kind of thing. If you're interested in that, the keynote from ROSCON 2019 is all about what we've been doing there, and I think that's probably the best introduction what's going on. There was an article that was on the robotics. It's that COVID-19 first responders. I dropped in there. There was an article in Robotics Worldwide, and a group has actually been interviewing first responders and medical professionals about what they really need, because a lot of times with robotic startups, like it ends up being a solution looking for a problem, and I think it's very interesting to actually interview people and understand what problems need to be solved and what things can actually be solved with robotics that people really need fixed, versus the sort of alternative approach, which is we build something and we try to find a use case for it. So I thought that was just a really interesting watch. So COVID notwithstanding, there's just, I think that everyone's kind of settled into the long haul. There's just been a lot of really good tutorials and work coming out lately. There's just been, just this week, there's been a massive amount of SLAM and perception related work that's been released. It's kind of like amazing what's come out this week. First, there's a really great SLAM library for Python that just dropped this week called PySlam. I haven't gotten to take a look at it. It looks fully featured. I take a look at it. MIT, the Spark Lab at MIT actually released a ROS package that does simultaneous, the SLAM plus basically metric reconstruction plus perception as a ROS package. Again, I haven't gotten it running on my Turtlebot, but it looks super duper cool. They actually have a full video tutorial. It's all open source.
Well, it certainly is the time to study robotics right now. Then I was wondering if you'd seen an uptick on the use of Gazebo or some other signs of people having more time online, but that might not be the right place.
I haven't looked. We don't, you know, I don't look at that stuff every day. I end up looking at it like once a quarter or when somebody asks a question. But I don't look at it all the time. Navigation-wise, like I said, there's just been a massive amount of stuff coming out. So there's, we actually created a new NavStack website, and the NavStack group has created a NavStack Slack, if anyone's interested in that. So NavStack 2 is out. It runs with ROS 2. They've actually run a marathon with it. So they've actually had robots right before COVID-19 got really bad in Italy, basically like 2 days before. They just ran this robot through a hallway at a busy school for 25 miles or 40 miles or some obscene distance. I think that's going to be published at RSS this year. So that's pretty cool. Also a really cool data set from event cameras from ETH Zurich. Let's see, other stuff that's going on. There's ROS 2 plot juggler just came out, so it's a really good way of plotting robotic data in ROS. And basically a new proposal for doing interfaces to Cartesian robots, which are X, Y, Z robots, which are basically the robots used for you know, any sort of material handling in medical and situations. So that's kind of cool. So actually, if we could build a standard interface, it actually should help us build more robots quicker, which I thought was kind of cool.
That's great. Hopefully Rikke's going to talk a little bit about that later. So I'm looking forward to, you know, having both of you informing me about what we can do in lab automation, which is a topic we haven't really covered yet.
Cool. Yeah, just I'm going to drop a bunch of other stuff. World Move It Day is coming up on June 2nd. So if you're interested in learning about Move It, building out stuff on Move It is the ROS basically forward and inverse kinematics library. So if you want to take a 4, 5, 6 degree of freedom arm and move it around, that's your go-to package. So that's there. Let's see the other stuff, cool stuff that's come out. So the DARPA, sorry, I'm copying and pasting stuff over from EX. DARPA Sub-T challenge. At Sub-T, there was actually a full photogrammetry booth set up and sponsored by DARPA. So all of the competition robots at the DARPA Sub-T challenge basically went to this booth, got set on this little rotating platform on a green screen, and got scanned at super high fidelity. And we've basically recreated or created 3D models of them. So if you want to see those robots, those search and rescue robots, and see them up close, you can actually just check it out. It's on Sketchfab right now, which is...
That's fabulous. And in fact, one of our speakers last week was talking about, Keay was talking about the Australian DARPA Sub-T challenge robots. So it'll be good to see them there. Well, that is a lot of link love there.
Yeah, I'm trying to be better about getting this stuff out because I end up seeing all the cool stuff, and there's a lot of projects that get out there, but you know, it doesn't get circulated as much as I think it should. I got 2 more. There's been a lot in the past month on just like legged robotics, but not like you know, unaffordable. Like I can't actually get a hold of one unless I have $10,000 legged robotics. So Stanford actually dropped their hexapod or their quad, which is the pupper, and simultaneously the Champ hexapod now has a full ROS interface, which is pretty cool. So both of those basically bring more legged robotics into ROS, which I thought was pretty cool. I'll drop those. That's most of what's going on this week. If you're interested in learning about vehicle autonomy, a bunch of people sort of working on AutoWare, we're putting together like a 16 one-hour completely free series of lectures on how to use AutoWare and all of the basics of building your own autonomous vehicle. So hopefully I'll have about 2.5 hours of just introduction to ROS2 and how to use ROS2, all Dockerized, and you just drop it on your machine and it's ready to go. The hope is that'll drop about mid-May, somewhere in there. Might mid-May, maybe late May, we'll see. But that's going to start then, and there should be one class about a week. Other than that,
Oh, cool.
there's a bunch of AIA-related perception things also happening in mid-May. So if you're looking for more webinars related to like perception hardware, I'll be giving a talk there, but there should be, it's basically the replacement for the Vision Show, which is the big AIA camera vendor and application show out in Boston got canceled. So now they're doing it all online. So that might be worth checking out. I think it's free. I think you just have to register and you can kind of put it on in the background.
That is one of the big pluses that's happened right now is a lot of the big shows have been canceled. And instead of costing you hundreds, if not thousands of dollars to go to them, they're trying to convert to online and often offering things for free just to persuade people that it's, you know, going to be valuable or just as good.
Yeah. No, so, I wasn't super excited about going to Boston for it, so now I can just do it from the comfort of my home.
That's a win. Oh, this is great. Well, I'm going to ask Nikolaus Correll from Robotics Materials to tell us a little bit about what he's doing next, and then we'll speak to Rikke Rasmussen after that. Over to you, Nikolaus. We need to unmute you.
Okay. This is not the first time I'm using Zoom, but still, every time. So I will screen share if possible.
Yes, please.
So thanks for having me. Good to see everybody. It seems the majority of robotic companies are in Boulder nowadays.
Well, there's a great community in Boulder, I have to say, and it's really good to have 2 Boulder startups joining us today. Just letting everybody know, the screens automatically resize when there's a screen share, so it wasn't anything at your end, it's just what Zoom does.
Well, we are building robots to help manufacturers to create, to increase efficiency without any programming. And with COVID-19, we're really sandwiched in between a tremendous opportunity and a tremendous catastrophe. And I think the opportunity is really robots could help us to get to 50% staffing level that is mandated right now in Boulder. So we at Robotic Materials, we're not allowed to come in, but only 50% of the workforce. The robot can help to help with social distancing. So if you have a robot that drives between people, or you have line workers and you replace every second person with a robot, you might help with that. And finally, robots could help us with reshoring manufacturing. And I was hoping could engage Ian in a conversation about manufacturing his robot for him with the people that we are currently working with. This is the opportunity. I will come to the actual reality at the end of the talk. So that's the product, how it looks like. It unifies mobility and manipulation and can drive around the factory floor, but then can also load and unload itself, do kitting, bin picking, and a simple assembly work. I have a little video, I hope that comes through, that shows some of the capabilities. We've been working on this for like 3 years now, and it's a lot of CU Boulder research that we took. And essentially, we're using deep learning to find things and then use 3D perception to actually grasp them using force control. And then we use semantic reasoning to plan actions for the robot. So the robot can say, oh, I need this and this and this, so I have to go here and then bring it over there and then later assemble it. So this is a kitting task. We always participate in a World Robotics Summit in Tokyo, and we got the highest score with the kitting, but assembly Fanuc won. This is shelf restocking. I think it's also a potential application for retail right now in particular. I think this is the video coming to an end. There are tons of videos on the website if you care. So the real key thing we offer is no programming. Instead, we thought about things that manufacturers want to do. So for example, this is a depalletizing task, and what we have is browser-based interfaces where you can train the robot or do you tell the robot that you want him to depalletize where the pallet is, how the product looks like, and then you get like a tablet where the workers can deploy buttons, and when they press them, the robot does it. This is what I already told you. The secret sauce is a combination of these three things. I think that's important because for a long time, roboticists thought we can do everything with feedback control, and many companies right now do that and call it AI. And others in the 80s thought everything can be done symbolically. And then again, we saw a big phase of deep learning or deep reinforcement learning instead of doing controls or actually planning. So we try to combine those things. The customer that we have is happy with the solution. It gives them more product they can make. So the people that have been doing stuff the robot does now are now doing other things. And so they get like $8,000 more product a month and can really easily use that. And we see how things go up. The problem is though really that right now we do have, I think it's 30 million unemployed people. And so at the company we are currently at, people are actually furloughed. So some of them have lost their job. Others are furloughed because there's zero demand in toner cartridges right now because there's no offices going. And then we also have something in Colorado, at least, which is a $600 CARES weekly stimulus, which is paid in addition to the unemployment benefits. So people actually don't think that the workers will come back, because why would they get their old job back if they could just, I mean, I don't know what they're going to do, but many people might choose so. And I think a lot of this could be avoided if you had robots installed correctly and, you know, use these things and then are able to grow and, you know, shrink your workforce accordingly. But right now, I think very few decisions can be made in a completely unpredictable environment. So that's the team. We have 10 people right now hammering at these and waiting for the customers to come back to let us into their factories and test things. So I think that's my presentation. So if you have, I'd love to discuss this. I try to frame it a little bit in the COVID pandemic and what we can do right now. And I guess you have very similar challenges.
Thanks so much, Nikolaus. And I think this is exactly right. It's good, bad, and ugly for robotics startups in this challenge. Everybody says we can see the demand for robotics growing, but it's not necessarily an immediate benefit for companies. And indeed, you've raised some very good points about the labor issues at the moment, where I'm not certain that any of us know what the way forward is going to look like. So I'm looking forward to really interesting discussion in the chat around your presentation, and some good questions already coming up. In fact, some are asking if your presentation can be shared. And I'm actually aware that we will want to do I do have a retail forum coming up that I'm going to want to talk to you about as well. So I don't know if we're facing a normal yet, but the new normal, retail is definitely aware of robotics and very interested. Now, Rikke, are you there? Let's hear from you about liquid handling robotics.
Right, yeah, so I've been listening in for the past 6 weeks, and I kind of thought that the type of robots I work with on a daily basis really deserved a shout out, because they are absolutely central to our COVID-19 testing program. And by we and us, I mean the world and humanity at large are highly, highly dependent on this particular class of robots right now to scale up our testing. Part of the reason why COVID testing initially was really slow it's kind of, it relies on a fairly old-fashioned technology. And when I invented sometime in the late 70s, very early 80s, a biological technique called polymerase chain reaction. The very short highlighted version here is you extract the RNA from the virus. You need a certain quantity. You couple that with a short DNA primer and use enzymes to amplify, effectively make millions or billions of copies of the complementary DNA sequence to that RNA. And you can detect the presence or the absence of that DNA, that amplified quantity of DNA using fluorescent dyes with a technique called gel electrophoresis. You can do the same thing in real time through another very similar and closely related process called quantitative or real-time PCR, where the dyes are coupled in real time and run past a photodetector that outputs a digital signal effectively. Analog to digital, I should specify in this context. So this all relies on the movement of a lot of very small quantities of liquid. Ironically, I guess, having followed the news for these past 7 weeks, you are by now all familiar with the term reagents, which I think was probably not in the vernacular for most of you a couple of months ago, but by now I imagine you're all caught up. So in order to execute this polymerase chain reaction, you need all of the chemicals that go into the process of extracting the RNA first, and then another set of chemicals that go into the process, this enzymatic reaction of amplifying the complementary DNA. Those reagents are liquid. They're in liquid form, all of them without exception. And traditionally, these are moved around by a human. So if any of you have ever spent any time in a typical biology lab, you'll have seen what are called micropipetters, which are basically little air displacement devices. Think of them as a little bit like your solder suckers, actually. There's a plunger, there's a cavity, you can displace the air and aspirate a volume of liquid accordingly, and then dispense it into another container. You can imagine that doing this hundreds or thousands or tens of thousands of times for a human gets really tedious really, really quickly. In general, humans are terrible at that kind of task because it's incredibly repetitive. All of the liquids are going to be clear. They're in clear tubes. You're keeping track of like microliter droplets of one clear liquid going from one clear container to another clear container. The humans are not cut out for this. So both in the name of reliability, repeatability, and scale, we broadly try to employ robots to do this. And so this is where the liquid handling robots come in, because that is specifically what they are. They are a generic class of lab automation robots, XYC gantries with automated pipetters on them, usually fitted with like a 96 channel. Everything is a 96. I'm not going to go into the details of how and why we standardize on certain numbers in biology. Just take my word for it, we do. Or individually controlled. And so in order to scale up the testing, part of the reason why the COVID-19 testing was so slow to ramp up in the beginning is most labs don't necessarily have this kind of automation yet. For all that it's been around for better than 20 years, a lot of labs still didn't have access to it, or they didn't have the right programs on their robots. And it took, because there are not a lot of people who do what I do, which is program this particular class of robots. For a while there, our services were in very high demand. part of what goes into now having ramped up is all of these programs in diagnostic labs, in private labs, and public labs across the country are now programmed to actually execute these procedures. So, yeah.
That's
Suppose
fascinating.
because I'm out of time.
You're the
Oh,
robot.
I got 10 total. Oh, sorry. Halfway mark apparently. So, yeah, I think I think it's an interesting time to look at the lab automation in particular, because this polymerase chain reaction process is actually representative of the very, very earliest forms of lab automation. It relies on a series of temperature control steps. We initially will raise the temperature almost to boiling point, drop it back down to allow the DNA and the RNA to form a strong bond, raise it up a little again to provide the optimum temperature for the enzyme, raise it back up to melt them apart so they can form a new bond with another set of primers, and this is, we call it thermocycling. So in the very old days, this would be done by a human, would be standing there with 3 water baths at 3 different temperatures and moving a block around. And the very oldest PCR machines mimic exactly that. It's a beautiful example of how when we go to build robots, we initially try to make the robots do exactly what the humans are doing in exactly the same way. It isn't necessarily optimal because humans have certain design constraints, shall we say. So we're very good at moving things around, not very good at doing it many times over, and we're not very good at doing it for a very long time, but those initial machines did exactly that, and then we got a little bit smarter and realized that with Peltier elements, we could just like take a single solid block of metal and like change the temperature on that and cycle through that. But that means that all of this testing, aside from the fact that the reagent manufacturing itself is also highly, highly automated, partly because it has to be really clean. And when everything has to be ridiculously clean, as in like completely sterile because it's going to go into humans, or because contamination and the risk of either false negatives or false positives as a result of contamination is a huge, like has really, really big consequences. Robots are perfect for that because they don't carry germs. They are not germ factories the way we are. So anyways, yeah, so a big shout out to liquid handling robots and lab automation in general, because right now it's saving our butts. Almost literally what's required for all of us to finally go back to work. I wanted to briefly touch on the comment earlier about standardizing on XYZ gantry designs, because part of the challenge of being an automation engineer for laboratory automation is that all of these robots are proprietary. So they're proprietary hardware designs, they're proprietary software, everything is locked down. They all come with their own custom programming interfaces, all in some obscure home-baked language, which in a lot of cases, unless you're a fairly advanced user, you won't even have access to. So there is actually a, to the Bay Area, local company called Opentrons. They decided to buck that trend and build a cheap, by which I mean like $3,000 to $5,000 price point, as opposed to starting at $100,000 to $150,000. Liquid handler. It has a relatively small footprint, but it does also have the beautiful feature that the software is completely open source and is programmable in Python, which, you know, that has some benefits for sure. It's not, as a platform, it's not yet super ubiquitous in a lot of labs, and I guess there are a couple of different reasons for that. Not least being the lack of expandability and the lack of support, because when you run a clinical lab, chances are you don't necessarily have your own service staff, like you don't necessarily have people to ensure the uptime of these robots, but you can be sure that your production relies on them. Like if you're running a pharmaceutical production line and you are using liquid handling robots as some part either of your already vetted and certified R&D, or your already clinically certified production, then you can't make any changes to those instruments. You have, and I mean, you cannot make changes to those instruments. They cannot go down. Your business will break if those instruments go down. So without like a professional support network, I don't think it's going to be really hard to drive adoption of those open source and standardized models. So anyways,
those are great points, and
discussion.
I'm so glad that you brought the voice from the lab, because we haven't really discussed what's involved in lab automation. And as you said, it's really critical to the situation now. Ken, do you have any comments about that? Or Nikolaus? You know, I was thinking you guys have all got similar backgrounds there.
Well, actually, I'm curious what Nikolaus has to say about lab automation, because the problems there, we've looked at it a little bit. Nikolaus, what's your perspective?
My perspective, I've been looking into that a lot, even tried to start a company on it before the manufacturing. And I realized that there are very good machines for the individual tasks. So there are these open source PCR machines, the Opentrons. I see the robot to be the glue between those machines, driving around. And what then happened is the market is very small. It's a $4 billion market. Eppendorf has only $4 billion revenue, or $800 million revenue a year. So it's very hard to race on that and to get people really excited. Maybe now with the health crisis, it's a different story, but it is not very much money. Thermo Fisher makes $20 billion revenue, but they have many other devices. And so my last attempt was to actually convince Eppendorf to do something, but then they dropped the ball. They are looking into creating open interfaces to make things like this easier. But I think that was mentioned, it's really hard to hook up to these ecosystems.
It is challenging. I mean, I think one thing that's especially challenging in the lab environment, there are all these high throughput screening tools and techniques for managing, you know, doing assay tests, which are also being put into practice. By the way, there's a new effort at Berkeley to develop a very fast testing processing for COVID-19, and we're hoping to actually get someone from that lab, from that group, to be on this series next week. But one big challenge, as Andra noted in the chat, is that you have all this all the materials are glass and transparent, and in fact extremely fragile. So that makes it extremely difficult for robots to, you know, under normal circumstances, robots are not particularly dexterous. But if you start dealing with transparent glass materials, I mean, it's one of the most difficult, challenging scenarios you can imagine. So I think for anything other than fixed automation, that's going to be a big challenge, and I don't foresee we're going to be able to solve that in the near future. I'm curious if how others feel about it.
Can't you just put it in a different container, or put the vial in a holder?
Well, okay, I'll let Rikke answer that. I mean, I think in a lot of cases that there's a lot essentially invested in glassware because it has a number of properties. It's sterilizable, and it also you can use it to, you need to be able to shine light and look at the colors and properties of the material. So you don't want it to be opaque. The other thing, you couldn't put markings on it. Of course, you could probably redesign, but again, there's a huge investment in the status quo of all that infrastructure.
I mean, I
So,
can speak to this just a little bit because in a lot of cases, we are actually putting it in different kinds of containers. Plastics, especially single-use plastics, are becoming more and more ubiquitous, and not so much in academic labs perhaps, but in industry labs everywhere. Everything is plastic, where it's all single-use plastic, where because the trouble and the expenses associated with having to sterilize your glassware is huge, number one. There's always loss, and it just doesn't work with the automation. So all of the modern high throughput tools are designed for, disposable plasticware.
okay.
True.
Okay, that's interesting. Okay. So they can be transparent, but then you don't have any sterilization issue, and they can also be more, less fragile as a result.
Exactly. But as the unintended side effect of that, the pharmaceutical industry is one of the single biggest plastic waste producers. So yeah, there's a downside for sure.
Okay.
Well, that's raising some really interesting questions that I was just tuning into what's happening in the biomanufacturing front and desire for California to lead the way there. But I'm thinking we're not there yet with robots handling the materials that already are in the lab and in the infrastructure, in the ecosystem around us. So I'm not holding my breath for an entire new wave of manufacturing technologies to replace the automation that is only narrowly distributed. Now, I know Jessica's going to give us a little bit of an update. If you're still there, Jessica, she's going to tell us what's been happening in the last month with open source COVID medical supplies and the helpful engineering groups. Hey, Jessica, you there?
Yes, sorry, I had to unmute. Yes, so hello, I am with Open Source Medical Supplies. Used to be Open Source COVID-19 Medical Supplies, but we wanted to stick around as an organization because this will probably happen again in the future or something like that, God forbid. But so we have had a lot of growth in open source COVID movement from makers over the last week. Let me see if I can share a link here. Okay, can everybody see that?
Yes.
Okay. So we take a tally globally of everything that is produced by local makers, universities, groups that are associated with OSMS. So this is not holistic. There are many people out there that we don't even know about. But when we started doing this tally, we had something like 100,000 medical products that people have been putting out to hospitals, to nursing homes, just medical providers in general. And we've ramped up to over 5.7 million. The United States has 3.3 million, but you can see we have makers all around the world that are coming together to address this breakdown in the supply chain, because PPE is getting intercepted before it gets to hospitals, and there's just not enough that can get there in time. So we're sort of a last ditch effort to make up for that. And you can also get involved in a more technical capacity. As you can see, the primary push has been with face shields and cloth masks as far as what do hospitals need right now to get out there. But helpful engineering is also a great group if you want to volunteer in a technical capacity as a roboticist or an engineer, because they're working on things like open source ventilators. And locally here in the Bay Area, we have an open source oxygen concentrated group to get them oxygen therapy before they would even go on a ventilator. People are working on ambu bags, all kinds of more technical engineering projects if you'd like to get involved with them. And I will link everybody, but if you're here local to the Bay Area, our All Bay Area PPE group has put out, I think, 8,000 cloth masks. We've been putting out thousands of face shields too. We've got Coca-Cola donated us these rolls that are over a mile long each and 2,500 pounds of PET plastic to laser cut, die cut face shields out of. And many of the makers have been ramping up their production capacity. Instead of just having 3D printers and laser cutters, a lot of facilities are getting access to injection molding, to die cutters, and things where we can really push out a lot more for hospitals. So it's pretty exciting. And obviously you could help by donating monetarily, but we also need materials. You know, we need rolls of plastic. If you have fabric that, you know, meets the filtration standards and breathability standards and whatnot, or even 2-part silicone or 3D printing filament, we would take any of that. And also you could always get personally involved if you so choose.
I can vouch for that. I've personally helped try to roll one of those 1 mile long PET
quite heavy
rolls. Yeah, it was not a one-person job. It was definitely a large work. And I know that there is still a lot of demand for sewers at home for making the cloth masks.
You are
I can second, third, and fourth that.
Yes, and I'm told that Rikke makes really cute masks as well.
That's right. Well, and I think we're trying to get them out to the general population as well, not just directly to hospitals. And I know there's some people locally who are talking about getting involved with the homeless community, since they don't obviously have the highest
Yes,
access to health and sanitation standards.
and I think we're starting to see, you know, as retailers start to come back online, as more of the normal life commences, then it's really critically important that everybody has access to protection.
Right.
That we need all the aged care facilities to be well supplied, and it often means in cases like that, they need face shields as well as a supply of face masks. It's sad that we still have calls from the medical community for face shields, for masks, and for the nasopharyngeal swabs. Apparently they're like gold dust, and we're going to talk about that next week.
Swabs for coronavirus tests.
Yeah, absolutely. And so Rikke, thank you for organizing that there are coronavirus tests happening. Now we need to get manufacturers like Rich and the UC Berkeley labs to be producing more of the swabs for the test kits. That was one of the first calls that we had as a community was, can you provide robots to help us make test kits? Because currently the university is getting students to do it, but they're trying to ramp up to millions. And, you know, that's when you do realize that there are some tasks that need to be done at a different scale to tasks that can be done by hand and or at home. But it's amazing the way the community has started to sort that out and really triage the situation.
Andra, on that note, I know there are actually a few people on the open bio side as well working on the test. I don't know if they're actually already in partnership with Berkeley or not, but I know BioCurious is an open source bio lab, and a lot of people working on that project, you know, do this for a day job, making coronavirus tests for various companies. And they are partnered with a larger lab that I am currently brain farting the name of because I'm not as aware of with the bio movement, but there are also kind of DIY biologists out there in the open source COVID movement as well.
That's great. Now, I know we're pretty much out of time. Hopefully there's some more questions that we can answer, but Ken, do you just want to tell us about not next week's COVID robots and us discussion, which will be a great recap, but the open problems in health robotics on May 19th?
Sure. Yes, we're planning an event that'll be free and open to the public. It will be on Tuesday, the 19th of May, and this will be earlier in the day. It'll be 10 approximately 9:30 or so in the morning, but a half a day of talks about open problems in healthcare and surgical robotics. So I'm sorry, that is howling. It's 8 o'clock, so I'm sorry about that. We have a great lineup of speakers, and we'll share that with everyone, including the CEO of Intuitive Robotics and VPs of RS and Verb Robotics. We also have Robin Murphy is going to be giving a talk or a conversation, and the whole focus of it will be on open research problems. It's directed toward researchers, students, and faculty, researchers in companies, but what are the problems that we cannot solve today? And we'll be certainly connecting with the special new range of problems that have risen in the context of COVID-19, as well as a broader range of problems across the board. So Andra is a co-organizer of this, along with Tom Lowe from SRI, and we welcome you all to attend. And we don't have a website yet, but we will soon. So
we will tomorrow.
Okay, we'll get the word out to you, but that'll be free and available online through Zoom.
Thanks so much, Ken. And look, thank you everybody who's spoken tonight. We're going to finish the recording now, but hopefully you've all got time to stay if there's some more questions in the discussion and discussion between ourselves. But I am saying good night for the recording.